Hello everyone, this is Priyanka Gopinath and today we are going to review the chapter Matter in Our Surroundings thoroughly. Now, what is matter? Anything, any substance that has mass and that takes up space by having volume is considered to be matter. A brief history as to how people classified matter in the olden times. According to the early Indian philosophers, matter was made of 5 basic elements: fire, water, earth, sky, and air. These 5 elements were collectively known as the Panchtattva. Even the ancient Greek philosophers had a very similar classification. But modern day scientists classify matter based on their physical and chemical composition. Let us now look at the physical nature of matter. All matter is made up of very small particles. These purple spheres in these images represent the particles. To find out the size of these particles, we will conduct an experiment called the potassium permanganate experiment. When we add potassium permanganate to water, the color of the water changes to pink. Now, we will dilute it by taking 10 ml of this concentrated solution and add it to 90 ml of water. This process of dilution decreases the color intensity of the solution, but the solution still remains pinkish in nature. From this, we can conclude that a visible particle may consist of smaller invisible particles like molecules and atoms. So to conclude, the particles of matter are incredibly small. I mentioned a may. This implies that all of this is just a theoretical approach and practically finding the size of an atom is impossible because it is very small. Okay, now let us move on to the characteristics of the particles of matter. First characteristic, the particles of matter have space between them. This space is called as the intermolecular space. In this image, we can see the red region between the black colored particles. This red region represents the intermolecular space. Second characteristic, the particles of matter are continuously moving. This implies that the particles possess kinetic energy. Therefore, this theory is considered to be kinetic theory too. Another fact to note here is that as the temperature increases, these particles tend to move faster. Therefore, kinetic energy is directly proportional to temperature. Third characteristic, particles of matter attract each other. This attraction is called as the intermolecular force of attraction. This is the force that keeps the particles together as a single entity. States of matter. This year we will only focus on the 3 main states of matter, which are solids, liquids and gases. The first state, solid state. Take a look at all of the examples we have in front of us. All of these are things we have come across in our regular life: chairs, trees, backpacks, hats and cars. All of these are examples of solids. These are the properties of solids. Solids have a fixed shape and volume. Their particles are tightly packed with negligible intermolecular space. The compressibility of solids are negligible due to the very little intermolecular space between the particles. The intermolecular force of attraction in solids are very high, and this is what causes the very close attachment of the particles. The rate of diffusion, which is the movement of a substance from an area of high concentration to an area of low concentration, is very slow in solids, again because the particles are very close to each other. The second state of matter, liquid state. Water, which is extremely essential for us to live, is an example of the liquid. These are the properties of liquid state. Liquids have a fixed volume but no fixed shape. So when you pour a liquid into a container, it takes the shape of the container. The particles are loosely packed compared to solids. They're difficult to compress again because they have little intermolecular space. The intermolecular forces of attraction are lesser compared to that of solids, and the rate of diffusion is higher compared to solids because the intermolecular force of attraction is lesser compared to solids. Let's move on to the third state of matter, the gaseous state. Again, air, which is extremely essential for us to live, is a mixture of different elements in the gaseous form. We will look at this in detail in the next chapter. These are the properties of gases. The shape of gas is not defined, neither the volume is defined. The particles are very far apart each other. All gases are highly compressible due to the maximum intermolecular space. This property allows large volumes of gases to be transported easily. Furthermore, the petroleum gas we use in our kitchens, the oxygen supplied to patients in hospitals, and the compressed natural gas, also known as CNG, which we use to fuel our vehicles, are all examples of compressed gases. The intermolecular force of attraction in gases is negligible. That's why the particles are very far apart. The rate of diffusion of gases are very high. This is the reason why we can smell the tasty food being cooked in the kitchen. This was part 1 of the chapter. For the next part of this chapter, please click the link in the description box. Thank you.